Hello, welcome to this EGR 185 tutorial. This is the second of a two-part series where I talk about state machines. So we're going to start out by coding the state machine that I drew in the last video. Alright, so you see I have my blank sketch here. We're going to start filling it in. And I've already written this code, so I'm going to cheat a little bit and go ahead and just copy in some things. So those are going to be my pins. If you remember, define is a macro, so any time I type these letters, so B pin, it's going to replace B pin with 3. So now we're going to get the enum part of our state machine. So we're going to define our enum, and we'll call you states. And then curly braces. We're going to have 4 states. Start. Oops. 1 right, 2 right, and 3 right. Close our curly braces, and there is our enum. So now we've got to declare our enum, or instantiate it, pardon me. So we're going to do this global variable enum states, and we're just going to call it state. And we'll initialize it to start. All right. And then finally, we're going to have global variables for our inputs. So you always want a couple of global variables. You want a global enum variable for your states, and you want a couple of global variables for your inputs and or your outputs. So we're going to make these ints, and we're going to call them red, green, and blue. If you haven't seen this before, you can declare integers or anything type of variable on the same line. So this would be the same as writing int r, int g, int b. But it just is a little shorter, a little bit of a shorthand trick there. Great, so I'm going to cheat again on the setup. Oh, we got to save this. Give me 1 second. And I'm just going to copy and paste over from my master code to set up the LEDs and the buttons. So let me talk about the buttons really quick. I will post a schematic, so if you want to copy my button schematic, you can do that. But you'll want to make sure that you set up the pins that your buttons are connected to as inputs. So what happens is you press the button, a connection happens, and it sends a voltage into one of those pins. When that voltage is read as high, as a level high, then we're going to do something. I will get to that in the loop. So let's move on. The first thing we're going to want to do, and this is generally true of most state machines, is you always check each one of your inputs. So if one of your inputs to your state machine is a ultrasonic sensor, you'll want to read your ultrasonic sensor right at the top of the loop. If it's a line sensor, same thing. Read that sucker right at the top of the loop and then go into the logic. So we're reading our buttons. So we're going to say R equals digital read. And we're going to say R pin. And then we're going to copy that. And we'll just do green pin, and blue pin. Great, so now every time the loop runs, it should read each of the buttons and check and see if they're pressed. So now we got to figure out what we do when they're pressed. Well, we know we got to enter the state machine, so I'm going to put a comment in. Now, another feature of state machine codes is you always want a switch and case statement. Well, pretty much always. When I say always, I don't always mean always. If that's confusing, let me know. So a switch statement, it really helps you categorize your states. So we're going to switch based on a state, our state variable. Remember that we declared at the top up here. So based on what that is, we're going to do different things. So we need curly braces, and then we write our case. A case statement is written case, value, colon. And then we always need a break statement. So I'm going to fill out the skeleton of this before I start writing anything else. So we need a start, 1 right, 2 right, and 3 right. So I'm going to take a second to just talk about the switch and case statement here. If you haven't encountered this before, this piece of code checks the variable in the switch parentheses, and then based on which thing that is equal to, it goes to that case. So if state is equal to 1 right, it'll jump down to this 1 right. If it's equal to 2 right, it'll jump down and run whatever is in this case statement. Okay, so now let's talk about what we want to happen in our case statements. So if we are at start, what do we need to do? Well, first we got to check our inputs, if our inputs have happened. So, because we don't really want to do anything unless a button is pressed. So if, we'll put a comment in here. Check for button press. So we're going to say if R is red as high, remember R is our input, or green is high, or red is high. Oops. Then we're going to go through and do our state machine stuff. So what is the sequence that we're trying to detect? So we want the user to press the, oops, I did that. So what is the sequence we're trying to detect? We want the user to press the blue button, and then we want a green LED to flash if they do. So let's write that. If, V is high, then we're going to flash the green LED. And then we have to do something else. We have to change states, right? Because now we want to move to the 1 right state because our user got 1 right. Now what happens if they press a button and they don't press the blue button? Oh, I missed some parentheses. Well then, so we're in the if button pressed if, right here. But we found out that the button pressed was not the blue button. So in that case, we need to flash the red LED. And I'm going to leave these as comments for a little bit and just copy and paste them in later because I'm assuming all of you know how to flash an LED using delays at this point. I might do a video later where I show you how to flash them using microseconds, but for the moment, we won't worry about that. Great. So now we have some pseudocode and some logic that checks and does what we're hoping to do in the start state. Great. So now let's repeat what we did for our first state for our case 1 right, and then case 2 right, and then 3 right. So I'm going to actually copy what we had in here and paste it right here. Because again, when we're in 1 right, we got to check for those button presses. So we check to see if that red input is high, green input is high, and blue input is high. Remember, we read these at the top of every loop. But now we got to change the sequence. So we wanted to do blue, I think it was red and then green. Yes. Blue. So now we check to see if red is high, and if that's true, we're going to flash the green LED and change states. Otherwise, we're going to flash the red LED. So nice that we have those comments in there. We don't have to worry about filling that out right now. Again, we do the same thing for 2 right. Again, blue, red, green. So now we check to see if the green button was pressed. And then we finally come to case 3 right. So what do we want to do when we have 3 right? Well, if you remember from my first video, we wanted to do a little victory dance. And then what do we do? Well, let's comment in, we'll say victory dance. And then from there, we need to change state again. Well, we want the user to be able to play the game again, so we'll just change state back to the start state. All right, great. So I'm going to go through and fix the change state comments, but I'm not going to fix the LEDs. I will just show you how that works later. Okay, so let's go back to our start case. Now, if blue is high, we flash the green LED, and then we change states to 1 right. And then we get to do that in 1 right, but from 1 right we want to change to 2 right. And then when we're in 2 right, we want to change to 3 right. Okay, so let's verify our code, see how many semicolons I missed. None this time, great. So one thing I always recommend you do is after you finish something, before you hook it up, just try and step through it logically. So I'm going to start up at the setup. I set up everything, pretending like I'm the compiler or something. And then we enter the loop. All right, so we read red, green, and blue. I'm going to assume that blue is high. Okay, so blue is high, red and green are low. Now I enter the state machine. So the state was initialized to start, right up here. So that means that we're going to jump to this case statement, the start one. All right, now if you remember we said blue was high, so we check this case or if statement, and look, if red is high, green is high, or blue is high, we get to move on. So blue is high, we get to move to our next if statement, which also says blue if blue equals high. So that means we get to move into this statement. Hey, we flash the green LED and then we change the state to 1 equals right. Or to 1 right, excuse me. All right, so we don't execute this else statement. We don't have to do anything for these brackets. And then we get to this break statement. This break statement means we don't execute any more of the cases. So we jump past this case, and past this case, all the way down to this bracket. That's our switch statement. And look, we're done with the loop. So now we go back up to the loop and we read our inputs again. Well, let's say this time green is high. And we enter the state machine. If you remember, the last time state was changed to 1 right. So that means we don't execute this case statement. We jump down and execute this block of code. Hopefully going through that made some sense to you. If not, as always, please leave a comment or email one of your TAs. We're always happy to help. Great. So let's go ahead and look at the real code. This is the completed code. As you can see, I've filled in some LED functions. We'll just go down and show you those really quick. You digital write the green LED high, delay for 500, write it low to blink the green LED, same for the red LED, and then finally for the victory blink, I have a simple for loop that just turns the red and green on and off. All right, let's go ahead and load that up and play the game. As you can see, if I press the wrong button, I have the red LED turn on. If I press the correct button, the green LED turns on. And if I do the correct sequence, I get a fun little LED flashy dance thing. Thank you so much for watching this tutorial, and as always, please reach out to me or any of your TAs if you have any questions at all. We're always happy to help.